Seatbelts, everyone!
Hi, Ms.Fitz. So today I'm going over this equation right here. So this equation is referring to the definition of angular acceleration, which is represented right here, as you can see. The equation shows that angular acceleration is equal to the net torque acting on an object divided by its moment of inertia. Angular acceleration describes how quickly the angular velocity of an object changes over time due to the influence of an external force or torque. The moment of inertia measures how mass is distributed around the axis of rotation. The greater the net torque acting on an object, or the smaller its momentum of inertia, the greater the resulting angular of acceleration. So now I'm going to show you an example of how this works. Okay, for the explanation, we all have to imagine Abe is standing on a playground at a merry-go-round. When Abe decides to give the merry-go-round a huge push and to make it start spinning, he's applying force, and we call that torque. So this is like the strength of Abe's push. The harder Abe pushes the merry-go-round, the more torque he applies. So for the moment of inertia, this is like how heavy and spread out the merry-go-round is. If the merry-go-round is very big and has a lot of weight distributed far from the center, it is higher moment of inertia. And the angular acceleration, this tells us how quickly the merry-go-round starts spinning due to Abe's push. So if Abe pushes really hard, which has more torque, on a lighter, easier to spin merry-go-round, it has less moment of inertia. The angular acceleration will be higher, meaning the merry-go-round will start spinning faster. So on the other hand, if Abe pushes the same amount on a heavier, harder to spin merry-go-round, more moment of inertia, the angular acceleration will be lower, meaning the merry-go-round will start spinning more slowly. So in summary, angular acceleration depends on how strong the push or torque is compared to how heavy or spread out the object is, the moment of inertia. So Abe's ability to make the merry-go-round spin fast or slow depends on how much force he applies and how easy or hard for it is to have the merry-go-round start moving around. This equation is also basically F equals ma.
Unreal!